Hi friends, you're welcome to the Nerd Lab. This is the second video on the edition of the audio project starting from the preamplifier, and today I want to show you how to link your preamplifier with a power amplifier. So without wasting time, let's get started. Now, I have explained in my former video how the jrc4558 IC works. So for those of you who hasn't watched that part, I recommend you check my other video so you'll never miss a part. So when we talk about preamplifier and power amplifier, what is the difference? In a very simple term, the difference between a preamplifier and a power amplifier is the difference in the power that dissipates. So you have your power amplifier normally in the range of more than, starting from 10 watts and above, while you have preamplifiers from the range of 2 watts below. So preamplifiers are normally lower in power dissipation to a power amplifier, and normally preamplifiers are used to feed power amplifier to further improve their amplification. So that's the difference between the two. While power amplifier has a lower output resistance tolerance, preamplifier has a higher output resistance tolerance. So using our jrc4558 to feed a power amplifier, we have the 4558 as preamp, and we have our power amplifier to be a tda2050, which I normally call it tda2050. These are very common amplifier ICs that you can see almost everywhere, and they're very cheap. So the power amplifier is a 5-pin terminal, and it's very easy to configure. So the tda2050 is superior to the tda2030 and tda2040 respectively, as the tda2030 dissipates just 15 watts of power at the maximum of 18 watts in single IC. This tda2050 dissipates up to 50 watts. So you can see the wide difference, and it also has a higher voltage tolerance, while the other one remains at positive and negative 18 volts. This one still tolerates up to positive and negative 25 volts to be able to dissipate such power. Alright, so the configuration is very easy. You have the first pin to be the inverting input, the second pin is the non-inverting input, so the third pin is the negative power supply, the fourth pin is the output speaker, the fifth pin is the positive power supply. So the same applies to the second. So in this configuration, we're going to use two tda2050 because our input preamplifier is a stereo type, so it has dual operation amplifier, and with that you could design a stereo preamp. So with a stereo preamp, you could use two power amplifiers to drive two different speakers. So I'd like to explain the configuration of the power amplifier a little bit. So this is our positive supply rail, and we have positive 18 volts here. It's a split power supply. So we have our positive 18 volts and we have our negative 18 volts below here. So both of them are actually linked together, just like you have the power supply is also linked together. So the fifth pin, which is the power rail is connected to 18 volts, while the negative power rail is also connected to negative 18 volts. So you have rail to rail power of 36 voltage. So moving on, we have the pin 4 fed to the coupling capacitor of 1000 UF and then fed to a speaker. So the speaker could be anything within the range of 8 ohms to 3 ohms respectively. Any lower than 3 ohms is going to make the IC suffer, and any higher than 18 ohms, well, you simply start to lose quality power dissipation. So we have gain configuration here also. So the gain is set in between the output pin, which is the pin 4, and the inverting pin, the non-inverting pin, which is the pin 2. So we have 22 kilo ohms resistor to set the gain at. The gain is actually variable for this, just like we have in the tda, and the gain is set to about 36 dB respectively with this configuration. So for further explanation about setting this gain properly, you could refer to the tda2050 datasheet. It's a general document out there that you can actually find. So in real term, I'm going to explain how this gain works. If you further reduce the resistance that is used to set the gain, like for instance you put 10k, if the power dissipated at 22 kilo ohms setup, so there are actually two resistors that are responsible for setting the gain. So one is the threshold and the other one is the gain in here, and so you have 680 ohms here also, while you have 22k here. So if you reduce this value to 10, the power dissipation is going to reduce. If you increase this 22 kilo ohm to let's say 30 kilo ohms, you are going to gain more power on the output, so the amplification increases. While on this other side you have your bootstrap capacitor as 22 UF fed through a 680 ohm resistor to ground. If this resistance is reduced, the amplification starts to increase, and vice versa. So those are the two configurations that are responsible for setting the gain at the output. But to achieve a very clear output, high quality output, and perfect configuration, it is set to 22 kilo ohms resistor and 680 ohms respectively. So that is that about configuring the gain. Now you have the inverting input as the audio source. It is grounded with 22 kilo ohm resistor. So this is a signal sink resistor to clip off unwanted noise and to mute it at idle mode. So this way you are not going to have the IC picking unwanted sound when there's no audio coming in. You have the 4.7 UF capacitor with the coupling capacitor fed through a 10 kilo ohm limiting resistor. This is to avoid excess power feeding the power amplifier. And you have the 10k variable resistor used as volume. So with this you could control the input threshold and increase or reduce it to any level you want. So these are filter capacitors, your 104 and 1000 UF respectively. The same applies to the negative as well, even though it's not in the configuration, but we can just add it now. So again you have 1000 UF microfarad and you have 100 nanofarad capacitor, which is the 104. Alright, so you mind the polarity of the capacitor here is very important. Since it's a split power supply, the orientation of the capacitor, this second capacitor is electrolytic, while this one could be ceramic or it could be carbon film. But this polarity is very important. So the 1000 UF is polarized to positive, since this is the positive rail, and looking at it here, the polarity is gone to the ground since this is a negative rail. Make sure you understand that. So the same explanation that goes for the first channel goes for the second channel. The configuration is the same and doubled. So this way you could have the same thing going on the left side and the same thing on the right side. Volume. Alright, so the same power is used to feed the preamp. This economizes and avoid for excess configuration and stress. So you have the power coming from the power amplifier through a diode 4007 here, and is limited through a 560 ohm resistor. So this current limiting resistor reduces the current from the high voltage side to the preamp, since the preamp doesn't really need much current to operate anyways. The same thing happens on the negative side, except that the diode again is also polarized, just like you have it in phase here. The reason is the split configuration I was explaining here also. Biasing the configuration, again you have the limiting resistor and then it's fed. Now on the norms, the jrc4558 configuration still has the capacity to withstand up to 18 volts, the maximum of 36 volts rail to rail. But just to ensure more reliability and to get rid of unnecessary stress on the IC, we have further regulated the voltage and made it stabilized at constant 12 volts. So with this, Zener diode could have 12 volts input. Another reason for this is in case the power amplifier is fed with voltage that is still more than 18 volts, this IC would still work without any problem. By the time it is fed with up to 20 volts or 22 volts, the rail to rail voltage becomes 40 volts or 44 volts, which would have been too much for this preamplifier, and at that point could burn it up. That's the reason why this is regulated, because on the norms this still have the capacity to tolerate up to 25 volts and the power amplifier will still be working, which will not be applicable to the preamplifier since it would have been at its limit by then. So again, you have your filter capacitors here, 104 and 220 UF, electrolytic here, ceramic or carbon film. So you have your input configuration and the same similar configuration that you have with the gain and the threshold applies here as well. So you have your decoupling capacitor 10 UF fed into the volume through a 1 kilo ohm limiting resistor, and then it's fed to the power amplifier. So I broke down the explanation of how this IC worked on the other video that I made, and make sure you watch that so you can understand how it worked. So then finally you have your input, your right input, and then you have your left input. So if you feed your input with audio sound, either a media device, your Bluetooth player, your mobile phone, computer or anything, the sound is fed here and then it's amplified and you have a higher version of the sound output. So the purpose for this preamplifier linked to power amplifier in conclusion is that there's limits to how much power you're going to achieve using just ordinary power amplifier. And by the time you feed your preamplifier with power amplifier, it does more than just the preamplification, because you will now have almost up to twice the amount of power the amplifier is dissipating just by feeding a preamplifier with it. And there's no magic involved than the fact that the preamplifier just works by multiplying the sound amplification, and you can have a louder version than you would have feeding the power amplifier directly without preamp. So if you like this video, share, you can like and subscribe, and stay tuned.